unicast, multicast, and broadcast. So in IPv4 addressing, there are broadcast patterns for devices to find or know about each other. So we're going to talk about 3 of these in pretty good detail. IP communication broadcasts, right? So the questions become, what is unicast and what is multicast and what is broadcast and what is IP-directed broadcasts? Well, they're all related, but they're definitely different. So we're going to split them up and take the answers one by one. All right. What is unicast? Well, if you look at the IPv4 address structure, each has a network partition and a host partition, right? Now, there are different ways to send packets from the source device, and these different transmissions affect the destination of these IPv4 addresses. Unicast transmission refers to one device sending a message to another device in a one-to-one communication. So the unicast packet has a destination IP address, which is the unicast address to a single receiver. Now, since the packet is generated from only one source, the source IP address can only be a unicast address. And this, by the way, applies to all, regardless of whether the destination IP address is unicast, broadcast, or multicast. So when you look at the picture on the screen, it consists of 3 hosts. You see, a printer and a router connected to a switch. Now, the animation is going to show the host with the IP address 172.16.4.1 sending a unicast packet to the IP address 172.16.4.253. So when the switch receives the frame, it forwards it to the printer with the IP address 172.16.4.253. IPv4 unicast host addresses are addresses in the range 1.1.1.1 to 223.255.255.255. However, like I said earlier, there are many addresses in this range that are reserved for special purposes. All right, Smarty Pants, so what's multicast? Multicast transmission reduces traffic by allowing a host to send a single packet to a selected group of hosts that subscribe to the multicast group. So a multicast packet is a packet whose destination IP address is a multicast address. So IPv4 reserved address is 224.0.0.0 all the way through 239.255.255.255 is a multicast range. So hosts receiving certain multicast packets are called multicast clients. These multicast clients use services requested by the client program to subscribe to the multicast group. Each multicast group is represented by a single IPv4 multicast destination address. So when an IPv4 host becomes a member of a multicast group, the host processes packets arriving at the multicast address and arriving at the individually allocated unicast address. Oh, yes. See, routing protocols such as OSPF use multicast transmissions. Yeah, for example, OSPF-enabled routers communicate with each other using the address 224.0.0.5, which is reserved for the OSPF multicast address. Only OSPF-enabled devices handle these packets with a destination IPv4 address of 224.0.0.5. All other devices ignore these packages. Okay, so what is broadcast? Well, broadcast transmission just refers to one device sending a message to all devices on the network in a one-to-all type of communication. Now, a broadcast packet is either all ones or 32 one destination IP addresses in the host portion. Now, by the way, IPv4 uses broadcast packets. However, there are no broadcast packets in the next version up, IPv6. But you already knew that, right? Now, unicast packets must be handled by all devices in the same broadcast domain. Broadcast domains identify all hosts in the same network segment. So broadcast can be directed or limited. A directed broadcast is sent to all hosts on a given network. For example, a host on the 172.16.4.0/24 network sends a packet for 172.16.4.255. A limited broadcast is sent for 255.255.255.255. And by default, routers do not forward broadcasts. So broadcast packets do use resources on the network and allow each receiving host on the network to process this packet. Therefore, broadcast traffic should be limited so that the performance of the network or the devices is not adversely affected. So because routers allocate broadcast domains, dividing networks into subnets can improve network performance by eliminating excessive broadcast traffic. IP-directed broadcasts, yeah. Now, in addition to the broadcast address 255.255.255.255, there is a broadcast IPv4 address for each network. So this address is called a forwarded broadcast. It uses the highest address on the network. This is the address where all the host bits are 1. For example, the forwarded broadcast address for 192.168.1.0/24 is 192.168.1.255. So you see, this address provides communication to all hosts on that network. A host can send a single packet targeting the network's broadcast address to send data to all hosts on the network right from there. All right. Now, a device not directly connected to the target network will forward an IP-directed broadcast just as unicast IP packets are sent to a host on that network. So when a directed broadcast packet reaches a router directly connected to the target network, well, this packet is then broadcast to the target network. Oh, and by the way, due to security concerns and previous abuse by malicious users, routed broadcasts are turned off by default as of Cisco iOS version 12.0 with a global configuration command, no IP-directed broadcasts. Got it? All right, well, see, that's the lesson up to now. We've learned unicast, multicast, broadcast. Pretty cool, huh? So, see you in the next lesson.